Two questions haunt people who try DynamoDB. Why is my database throttling at scale, and why is my bill suddenly huge? Almost always, it's because they brought SQL habits to a service that works completely differently. DynamoDB is a managed NoSQL key value store, and you design it backwards, starting from your access patterns, the exact questions your app will ask. Picture an automated valet coat check. Hand over a ticket and your coat comes back in milliseconds, no matter how full the garage is. But you can only get it back by ticket. By the end, you'll understand why, and we'll run the one demo other videos skip. A scan that bills you for every item, then fix it live with an index. So, the mindset shift. In a relational database, you model your data into neat tables, then query it however you like later. In DynamoDB, you flip that, you write down the questions first, then design your keys to answer them. For an orders app, the questions might be, get one user by ID, get a user's orders, newest first, and find all orders with a given status. You list those access patterns before you ever create the table, because in DynamoDB, the keys fall directly out of the questions. You can only retrieve by ticket, so you decide your tickets first. Let's create one in the console. And notice the first big difference from RDS. There's no instance to launch, no servers to size. You just create a table directly. It's fully serverless and scales on its own. On this Create Table screen, you give it a name and define the primary key, and that's the real design decision. You also pick a capacity mode, which we'll cover shortly. That's it. No patching, no provisioning, a database engine. The table is ready in seconds. Here's the table and the vocabulary. A table holds items. Each item is one record, like one coat. Every item is made of attributes, its pockets, and here's the flexible part. Different items can have totally different attributes because DynamoDB is schemaless. You only pay for the pockets you actually fill. You can see our orders here, each with a user ID, an order ID, a status, and a total. No rigid columns, no migrations to add a field, just items with whatever attributes they need. Now the heart of it, the keys. The partition key is your ticket number. DynamoDB runs it through a hash that instantly decides which physical partition, which rack, your item lives on, so you fetch it in constant time. It must be high cardinality, like a user ID, so load spreads evenly. Optionally, you add a sort key, the peg position on that rack, which orders items within a partition and lets you do range and begins, with queries. Together, a partition plus sort key must be unique. That composite key is how you meek. That composite key is how you model relationships. That combination gives you the item collection, all the coats on one rack. Every item that shares a partition key sits together, ordered by the sort key. So all of user 101's orders share that user ID and differ by order ID. Now a single query by that user ID returns all their orders, already sorted, in one fast, cheap call. That's how DynamoDB models one-to-many relationships without any joins. You co-locate related items under the same partition key. Now the centerpiece, the number one cost mistake. There are two ways to read, query and scan. A query uses the partition key to jump straight to the right rack, fast and cheap. A scan reads the entire table, every single item, then filters. Watch the console. The scan returned 5 items, but it scanned all 5 and consumed read capacity for everyone, even items you didn't want. On a table with millions of rows, a scan reads and bills you for millions. It's the customer who forgot their ticket, so the valet walks the whole garage and charges you for every coat he touched. Avoid scan almost always. So what do you do when you need to look things up by something that isn't your key, like by status instead of user ID? The wrong answer is to scan. The right answer is a global secondary index. Here on the Indexes tab is our status index, a GSI with status as its partition key. It's a synced copy of the table organized a new way, so now you can query directly by status, fast and cheap, instead of scanning. A GSI is a second cross-reference disk that finds coats by a different label. 3 things to know: it's eventually consistent, it has its own capacity, and because every write updates it too, each GSI roughly doubles your write cost. There are actually 2 kinds of secondary index, and people mix them up. A global secondary index has a different partition key, supports a brand new access pattern, is eventually consistent, has its own capacity, and you can add it anytime. A local secondary index keeps the same partition key but a different sort key, just a different ordering of the same rack. It can be strongly consistent, but it must be created with the table, and you can have at most 5. The rule, a new way to look things up means a GSI, merely a different sort order means an LSI. A trap that surprises people. A table with plenty of capacity that still throttles. This is the hot partition. If you pick a low cardinality partition key, say a status that's only active or inactive, all your traffic jams onto 1 or 2 physical partitions, one overworked rack, and those requests get throttled even though the table overall is barely busy. The fix is a high cardinality key like user ID, or adding a suffix to spread writes across many partitions. Don't give thousands of codes the same ticket number. DynamoDB has 2 billing modes, and most beginners don't even know there's a choice. On-demand means you pay per request with zero capacity planning. It scales instantly to any spike, and it's the modern default. Start here, especially for spiky or unknown traffic. Provisioned means you set read and write capacity units up front. It's cheaper for steady, predictable load, and you turn on auto-scaling so it tracks demand. The danger with provisioned is over-provisioning, paying for capacity you never use. It's pay the valet per coat versus hiring a fixed number of capacity you never use. It's pay the valet per coat versus hiring a fixed number of valets by the hour. A quick but important one, read consistency. By default, reads are eventually consistent. DynamoDB reads from the nearest synced copy, which is usually current but can occasionally be a few milliseconds stale, and it's cheaper. If you need the absolute latest value, you ask for a strongly consistent read, always current, but it costs twice the read capacity, and it cannot be used on a GSI. So most reads can stay eventual, reach for strong only when you must read your own write immediately. You'll hear about single table design, so let me demystify it without scaring you. It's an advanced pattern where you put multiple entity types, users, orders, products into one table, using generic overloaded keys and item collections. So a single query can satisfy many access patterns at once. It's powerful at scale, but here's the honest part, you do not need it on day one. Starting with one table per entity is perfectly fine, and you can evolve later. Think of one mega coat check holding codes, bags, and umbrellas, sorted by type tickets. DynamoDB has a handful of power features worth knowing by name. Streams emit every change so a Lambda can react, perfect for leaderboards or replication. TTL auto-expires old items, great for sessions or shopping carts. Transactions give you all or nothing writes across multiple items. DAX is a microsecond in-memory cache for red-hot reads. Global tables replicate across regions, active, active. And point-in-time recovery lets you rewind the whole table to any second in the last 35 days. You won't need all of them at once, just reach for the right one when the moment comes. Finally, cost and the decision. The free tier gives you 25 gigabytes of storage plus 25 read and write capacity units. And remember where real bills come from: scans, a hot or over-provisioned table, and forgotten GS. Is that double your writes? As for DynamoDB versus RDS, choose DynamoDB for known access patterns at massive scale with predictable single-digit millisecond latency. Choose RDS or Aurora when you need relations, joins, and ad hoc queries and reporting. It's the automated ticket valet versus a librarian with a card catalog. And always tear down, delete the table and its indexes so the bill goes to 0. Get the code check, and DynamoDB stops teeing scary. Each service gets its own deep dive, so subscribe